So now we would go a little bit into performance tuning. First and foremost is that all of the integrator's metadata is cached. And expectation of integrator is that once it is running, its own metadata should never be read twice. So there is a table for it, but again, we have to understand that what is the bias of integrator is that it should all be cached. So if you, these numbers are high enough, but if you have to increase them, that's fine. You can increase them to 1000 if you want. But again, very important consideration is that integrator expects that its metadata will not be read twice. So never try to reduce these numbers. The standard values should be enough, but if you have to increase them for, if there are a lot of customization, that is also completely fair. Basically, cache size is the setting that I'm talking about. Another very important consideration for performance, as I indicated earlier, was synchronous or asynchronous. So first of all, synchronous delivery should be reserved for only exceptional cases. So by default, we never want two systems to be tightly coupled as a default. Of course, we use synchronous typically in case of, for example, we are talking to an automation system, we would go to synchronous communication, but as a default, we don't want to go there. And asynchronous is good, except for asynchronous creates a bottleneck that events go to EC and then we have to create processes to move from EC to IC. So that is where synchronous accept send comes in. That is oftentimes a saving grace by just making your asynchronous to synchronous accept send. Now your events would not stay in EC for long. If you ever seen that issue, that can be solved simply by doing that. What it's really doing is creating a extreme multi-threading, that every process that took to EC also then takes to IC. So that might spend a few milliseconds more, which is not going to be noticeable by the user, but that as opposed to if you had a single process taking care of 10,000 events every few minutes, then those that small overhead does add up. So that is why we always prefer to say synchronous accept send instead of asynchronous. And then if you ever have seen the result IFD screen or event maintenance, you see these check boxes there, always persist and persist event data. Those are really talking about the same concept as well. So just imagine if you're doing something synchronously, you don't have to store the intermediate data, right? If you, for example, logged a shipment dispatch, internally integrator figured out what inventory was on it, and then it is going to be sent to another system, for example, in form of a file. Integrator does not have to store the intermediate data, right? That's why these checkboxes come in. So these apply only for synchronous, because if they're unchecked, then integrator decides. And what would integrator decide? That if it's an asynchronous or synchronous exception, it does need it. So it would always log them regardless. But if they're unchecked and it is a synchronous, then it would not log that intermediate data. That is on the result IFD and event output level, versus on the right side, what you see on event maintenance is at the event level, like event arguments. Again, my default answer there is always that we check all of them. So even in case of synchronous, I want to see this data until we get to a very acute problem where we want to get that last bit of performance out of it. So again, the default answer is that I always check. Even if you have to uncheck it, leave the right side checked, because this is what tells you that this ship load happened for this trailer. And that is very important to easily find transactions later on. So even if you have to uncheck it in certain cases, always leave this side checked. But again, these are only there for synchronous. Then another thing what we can use for performance is, first of all, use synchronous accept send. Then if you install integrator by standard, you would see an SLIFD sender one task, basically, which is responsible to send to all systems like host, SAP, all of those. So disable that and create a task for each system. So you want to make sure that if you have 10 systems that you're sending data, you have a sender task for each of them individually. Then there is a nice switch available at the system communication level for inbound, where you have a run tran flag. If you set it to true, it means that the adapter, which is responsible for getting data, for example, reading a file, reading from a queue, all those, that is also responsible for logging the event, that is creating the part, creating the order. So that means that is doing a little bit more task. If you set it to false, that means that the adapter is only responsible for creating the download, and you would have a different process processing the download, which is going to be download runner. So that also creates a possibility that you, by decoupling them, you can improve the performance a little bit. And since I think 2012 version, this download runner task has an interesting parameter -e. Just by giving that minus capital E, what it tells is that it is going to use asynchronous runner to even further open up the bottleneck, and multiple asynchronous tasks would be processing those events. So that makes the inbound process very easy to handle. Then there's a specific query which always shows up on Oracle. So the query is well structured. There is nothing wrong in the query, but it basically, because your event statuses are such that there are a lot of events in IC status at a given point, sometimes integrator is not um, using the proper indexes. So if you just create histograms on Oracle, then this query no longer shows up as a bad query. So that's just a small tip. You just simply create a histogram as described here, and then this query would no longer. Otherwise, this query often shows up as a bad query when you're analyzing performance on Oracle. So these are some of the tips that always rely on caching. The relying on caching is very important, because sometimes the discussion goes as that, hey, this is slow in integrator. So integrator is never going to be your bottleneck as a general rule. But then when we do a trace shows a lot of noise, which is integrator's own metadata being read. And then oftentimes we get sidetracked and we are looking at those sequels. So don't even worry about that, because integrator's own metadata is going to be read only once. So again, rely on caching. And then the performance issues are typically on the communication level or processing algorithms level. Utilize the synchronous except send, and unchecking the boxes, as I described earlier on the result IFT, can give a little bit of more performance on synchronous. Tune the tasks, and always focus on the processing algorithm and communication layers.